this prestigious Global Ayurvedic Forum. And I could discuss with many of the doyens and the eminent pioneers in the field of Ayurveda. This is a great opportunity given to me. And while I have listened to Dr. Bhatt, the chairperson, giving very insightful introductory remarks, and then I could listen to Dr. Gangadhar, who was even very scholarly presentation, and I have full agreement of the principles of integration which he has actually put forward. I represent modern medicine, and in fact, I am a professor of hepatology, and I feel that there is a great scope and need for integration with Ayurvedic system of medicine, not only because I come from the part of the country of Ayurveda, but I believe that, Ayurveda, with many thousand years of standing and which has stood the test of time, has answers to many of the problems, which the world is actually facing. Many of the new challenges and the problems that we feel the modern medicine actually is facing may not be in fact new. These problems may be faced by different populations at different ages. And I feel that a traditional medicine which has stood the several thousands of years of history may have answers to these problems. The only problem is that you need to find the solutions from there. But however, there is a problem with integration is that for integrating, you need to have a common language. When I talk, you should understand, and I should be able to understand what you talk. So there needs to be a common language, and also many platforms for integration, for discussion. And I feel that this is an excellent platform. So with this, my introductory view, I will go for one area. I focus to one area for discussion. I will take up fatty liver disease, which is the commonest liver problem in the world today, and I will try to give an overview. And why I do this is this liver disease, this fatty liver disease. I take it as probably a prototype, and my viewers and listeners will be able to get an idea how in the modern medicine we deal with a case, we approach a case, and then probably I will throw open the research points and the needs for collaboration in each of these areas of fatty liver disease as an example for integration, the need for integration from my point of view. So, why I have chosen this, I know this liver is the focus of discussion today because the liver burden, the disease burden is actually globally increasing, and it will be posing a big challenge in the next decade. It may be because of many factors, because of the widespread use of alcohol globally, and here again, and the lifestyle diseases like fatty liver disease, which in fact is coming in the form of a pandemic now, and the viruses also, which is the references to which is already made. And I can tell you that the liver disease causes more morbidity than other sorts of diseases. Say, compare with the cardiac problem. A liver disease patient, cirrhotic patients will be admitted many times in a year for infection, say for ascites, say for acute kidney injury, say with the encephalopathy. And the suffering of the patient, the morbidity for the family, and you look at the cost also is going to be tremendous. This is actually very much compared to the diseases of other systems. And you just look at the projections, by 2035, in a decade and a half to come, the liver disease, the end-stage liver disease will be over prevailing the end-stage kidney diseases. So this is a big statistic, meaning that, the burden of the liver of the medical care is going to increase many-fold in the coming years. Now, let us focus on this lifestyle-associated liver diseases. What is this lifestyle disease? The lifestyle disease, in fact, is the metabolic syndrome, the scientific terminology. And what is this metabolic syndrome? This metabolic syndrome is due to an easy availability and access to high-calorie diet because of rapid economic growth, which we have enjoyed in the past few decades' time. And coupled with the fact that, we have got a very sedentary life, maybe personal life or occupational life. We need to spend less of energy because of mechanization, industrialization. See, we have got automobiles, we have got many of the robots even to do your mechanical work, So you need to spend less energy for your occupation, personal life. And that leads to obesity and diabetes and hypertension. So what is this metabolic syndrome? It is a central obesity and insulin resistance leading on to diabetes mellitus, dyslipidemia, and hypertension. So that is the metabolic syndrome. So this is a central obesity with insulin resistance. So these are the two key words which I'll explain in the next two slides. What is obesity? Obesity is, in fact, it is related to your body configuration. You put on more weight. This weight is mostly of lipid or fat. You put on more fat, compared to your height. So this, in fact, is a formula is there. You find out the body mass index is a formula. You calculate, you find out your weight in kilogram and divide by your height in meter square. So you get an index, which is the body mass index. That actually will tell you how overweight you are going to be. So an overweight person has got a body mass index of more than 25 and 23 is in the Asians. And you define as obesity if your body mass index is going to be more than 30 universally, and you need to have less body mass index for obesity in Asians, that is 25 only. So that means in the case of obesity, your body configuration would change, you will become more rounded up. And mind you, this rounding up is more with the fat and not with the muscles. And the second part of the terminology is the central obesity. Okay, it is not peripheral obesity, it is central obesity. The metabolic syndrome, what you have got is central obesity. Central obesity means that, you have the fat deposition in the trunk or in the axis, okay, than in the periphery, in the limbs. So that is it. So this truncal obesity, where you have got deposition of fat in the trunk, in the central axis, is associated with the visceral fat. It's associated with the visceral fat. You've got more fat in the tummy. And this, in fact, is measured with waist circumference. Waist circumference, in fact, would reflect your insulin resistance. If the waist circumference, which is a horizontal measurement at the level of the iliac crust, if it is going to be more than 19 male and 18 female, you have got a high insulin resistance. That means that, you have got to increase the visceral fat deposition. And this increased trunk fat deposition, there are two configurations again. This is like an apple or a pear. You call it an apple obesity or a pear obesity. Apple obesity is your fat distribution, accumulation is mostly above the umbilicus. It takes the shape of an apple. Or sometimes, it may be below the umbilicus, as in the case of a pear. You call it a pear obesity. Where this picture will tell you. The left is the pear obesity and the right is an apple obesity. Okay, and why do you want to distinguish between these two? If you have got a pear distribution, your visceral fat is going to make more problems in the liver. Whereas in the case of an apple obesity, your visceral fat will be associated with more of cardiovascular complications. So we have seen what this metabolic syndrome is, and this metabolic syndrome will be associated with the complications, like a liver disease, which we are going to discuss today. It may be associated with a cardiovascular disease, like heart attack, or may be associated with the cancers, like colon cancer, breast cancer, liver cancer, and all. It may lead to strokes and chronic kidney injury. Meaning that, if you have obesity and metabolic syndrome, your life expectancy is seriously shortened. If you're obese, you tend to live about 10 to 15 years less than what you are expected to. And if you've got morbid obesity, which is defined as a body mass index of more than 40, your life expectancy will be reduced by a quarter of a century. You die 25 years earlier. The importance is, again, is that, if you actually reduce your body mass index and you become normal, your risk will be reduced and your risk will become zero. So it's very important that you identify the process and then revert back for your healthy life and for a longer life. So my agenda in the next 20 minutes time will be to tell you about the epidemiology, some more about the epidemiology of the disease, the definition of the disease, the spectrum and natural history of the disease, the diagnosis, how we diagnose the modern medicine, and the treatment protocols available. And finally, I highlight the scopes for future research and areas for integration. But this sort of a systematic understanding is the key for us to find out, what areas of research where probably we need to have more of research, and then probably where we need to have more molecules, and then to find out the deficiencies, gaps in the knowledge, and where we seek the partners for integration. The integration, there's a need for integration when there's actually a gap in the knowledge or the practice availability in terms of medicines or interventions. And there is a possibility that another alternate system of medicine is likely to have the same sort of these modalities. So the epidemiology has given a bird's eye view already. If you just look at the global prevalence, it's 25%. That means that about more than 1 billion people, adult people, are suffering from fatty liver disease. In India, it is 29.62, and if you convert to figures, it'll come to about 300 million. And in Kerala, we have done studies, this is even higher. About 50% of the population has got fatty liver disease now. And this figure, if you compare with the standards, the statistics about 10 years back, it used to be 29%. In a decade's time, in fact, the incidence has actually increased by 20% of the population. So this actually is a growing problem. And this is the second commonest cause of liver transplantation the world over. This, the graph tells you about the distribution, the prevalence of the fatty liver disease in different parts of the country, in different countries of the world. You can see in the Middle East and South America is more than 30%. In Africa, it is less, still you find malnutrition. And in Europe, and 23.7, and North America also the same, probably the same rate. In Asia, including India and China, again, it is going to be a big problem. The difference between what you find in Europe and Asia, or USA and Asia, will be that in these areas, they had the problem about more than 30 something back, and they could control the epidemic right now, and they brought it, they're actually bringing it down. So the peak is past, and in fact, they're registering a descent there. But in Asia and in the Middle East, etc., the problem is in fact growing even now. So I think that is what is seen in the epidemiology here. And the same is the color code representation. You can find that, the brownish and the reddish has got a high prevalence. And you can find the distributions if you just look at the per capita income, you find more of a fatty liver disease prevalence. That means that, this in fact is a parallel to your affluence nature. And this is very interesting. This will tell you that the prevalence of obesity and overweight in fatty liver disease. You can see that if you look at USA, 70% of these fatty liver patients, they are overweight, and about 30% of them are in fact obese. But if you just look at in Indonesia, there the fatty liver, only about 10% is overweight, and probably less than 5% is obese. So why this difference? So it's not just what you eat and how big you grow in terms of body mass index. There are other determinants also, and this other determinant mostly is genetic and epigenetic. So in the world, some population, they are genetically predisposed for the fatty liver disease and its complication, and some people, in fact, are protected. Now we have identified that gene, is PNPLA3. Actually, this gene is associated with, and the sad point is that in India and Asia, the prevalence of this gene abnormality is very high. So that leads to genetics and epigenetics. So this is genetics, and what is epigenetics probably I will explain in the next slides. So the definition of the fatty liver disease is, if there is a pathological accumulation of the fat drops in the liver, more than 5% of the hepatocytes, due to insulin resistance and not due to alcohol. Because previously, the commonest cause of fatty liver disease used to be alcohol. So if you are not taking alcohol and you have got this fatty liver, this is defined as fatty liver disease. So you need to have very unified definitions, So a definition is very important to understand the process. I also recommend that, we need to have more idea about the epidemiology and biostatistics. So I feel that, this study should be the epidemiology and biostatistics also should be incorporated in the Ayurveda curriculum, so that we know about the disease burden and we have an idea how much we concentrate on certain areas. So that's my recommendation. So that's why I've actually given the epidemiology in a detailed fashion. So this is what is happening in the case of fatty liver. So when there's a fat deposition, it becomes more yellowish, it becomes more waxy, and probably it might begin a bit enlarged also. And then if you just look at the histology, this is the normal hepatocyte. And then with the fatty liver, you can find this lipid-laden propolis are there, vacuoles are there. These are lipid vacuoles, and then they go for inflammation, and you'll be able to find the changes of inflammation also there. So that's the next stage. If you look at the ultrasound scan, you can see that this is the liver and this is the kidney. And liver and the kidney just got the same sort of echo texture, you can see the same texture. But in the case of fatty liver, you can find this becomes more whitish than the kidney. So ultrasound scan is an easily available, cheap, non-invasive, and acceptable method for diagnosing fatty liver. And it has got a spectrum. Fatty liver disease is a spectrum of disease. You will just have fat in the liver, or you will go to the next stage of inflammation. And this inflammation lead to more fibrosis and cirrhosis liver, and then it can lead to a hepatocellular cancer also. And all this will actually encompass in the umbrella of definition of a fatty liver disease. So this, in fact, you can see from normal liver to the simple steatosis, it progresses to steatohepatitis and more fibrosis and cirrhosis liver. And you can see the histological changes also. For simple fatty liver, you can find inflammation there, both the lobular inflammation, and then it leads to significant fibrosis, and finally you can find nodules in the form of cirrhosis liver. This is a natural history of cirrhosis, fatty liver disease. About 2 decades back, well, the fatty liver to cirrhosis liver, that journey would take about 35 to 40 years, meaning that fatty liver disease cirrhosis patients are over the age of 65. So you will not find the cirrhosis liver due to fatty liver disease in less than 65. But now that this fatty liver disease is becoming more aggressive in natural history, that, about half of these people, they go for steatohepatitis in a short period of time. And from there, a quarter will go for cirrhosis in about 8 years' time. In the 11 years, you will develop cirrhosis liver compared to 35, 40 years back. About 25% of them, they will actually have a fast-track course, and about 3 to 7 years' time, they'll directly go for cirrhosis liver also. And the liver cancer is a complication of at any of these stages. So now we understand that over the decades, if you just look at the timeline, the fatty liver disease is becoming infinitely more aggressive now in the modern time. And now we look at the issue of pathogenesis, because the excess of nutrients, you accumulate your fat in the liver, you become fatty. And then this increased fat is not just because of the nutrients, there are genetic and epigenetic factors also. This epigenetics I will again explain. And then after some time, this fat, it goes for inflammation. What drives this inflammation will be the other factors like this lipotoxic factors, the inflammasomes, and then this apoptosis, etc. And once there is inflammation, from the hepatocytes, there will be cytokines released, which would actually stimulate the hepatocellular activation, which would lead to fibrosis and cirrhosis liver. So I think the next slide will I'll just give an overview. I will not actually elaborate upon that, This is very important that, this is how we should analyze and look into the molecular area, the cytokines, and then the transactions at cellular and subcellular level to understand this better, to find out the action of these biologicals or the drugs that we are, the molecules that we are going to develop, and going to act upon. So there are two major players here, the lipo tissue or the fat tissue and the intestine, from which they will release a lot of adipokines in the form of cytokines also, and that will act upon the hepatocytes, producing more injury and inflammation, leading on to many of the subcellular events and inflammation. So these inflammasomes are also, a product of the leaky gut, The gut is under fire, which will actually drive these inflammatory cytokines into the liver, which will actually lead to the hepatotoxicity. So now I will just tell you what this epigenetics is. You can see this actually is a mouse model. We use, this experimental models. That's probably another thing which you can also simulate in Ayurveda. Well, we need not actually look into the humans, or is it possible, You can look at the suitable animal models, and you can look at the cell cultures, and you can probably at the molecular level also we are able to manipulate. So we can conduct the experiments, not just the human experiments are towards the end. We can have molecular experiments, tissue experiments, and then animal experiments, and the human beings comes very, very late. This, in fact, is the mice, are the same age. You can see that this is an obese mouse, and this is a normal mouse. And this mouse, it has got the habit of coprophagia. It will be eating the stools. So what the experiment is that, this in fact mouse is fed with the stool of this obese mouse. And after some time, you can see this is the result. The small mouse, in fact, became a very super obese mouse. And that is because, of something in the fecal matter, which is modifying the genetic expression of the non-obese mouse. So here, we now know that, what is the stool, in fact, is the fecal microbiota. What is in the microbiota? The gene in the microbiota. You get a lot of genes in the intestinal microbiota, and those genes will be influencing your innate genetic expression. So that, in fact, which is modifying your genetic expression is called epigenetics. So epigenetics has got a very important role in many of the diseases, especially fatty liver disease. Now let us come to the investigations. I just take you through some of these investigations which probably could be stimulating you, because you'll be knowing that, how the modern medicine, in fact, is expanding right now. The modern medicine versus Ayurveda, which I feel that, Ayurveda is static for not just for decades, for centuries it is remaining static. Whereas modern medicine, though it has got a history of only 200 years, it is expanding, or rather exploding. This is not just by the increase in the research in our own modern medicine area. We actually adopt the rapid changes of technology innovations, in other areas also, like technology, like artificial intelligence, like molecular biology, like electronics, etc., etc. So I think this is not a monopoly of modern medicine. Whoever is interested in the subcellular transactions, you will be able to, and you should be able to adopt these technological changes, and then probably you can expand that. So this is actually, we used to, understand the fibrosis only with liver biopsy, which is very invasive and it's a very risky thing. But you look at this fibroscan. Fibroscan, there is actually a probe which will actually induce a sound wave vibration of the liver tissue from exterior, and you try to calculate the energy which actually is dissipating when actually is coming to the rest. After this excitation, the liver tissue is coming to rest, and how much energy is actually dissipated is actually measured and converted into a measurement which will actually measure the liver stiffness, which actually corresponds to fibrosis. And now we just buy this machine, maybe a bit costly, probably cost about a crore, but this is a technological advancement. This is the artificial intelligence, which we are actually using. Now we can avoid liver biopsy in all these patients. Just with probably a few minutes, you will be able to find out the liver structure. And the same thing we can be able to find from the shear wave elastography. We can find that in a particular part of the liver, how much a part of the liver is fibrotic. Then you may be able to find this from the shear wave elastography. This is actually a mass spectrometry. The magnetic resonance, this is the magnetic tube. And there you can add a software again, There actually, this is actually machine learning, or again, artificial intelligence. You'll be able to, this is the normal liver, you can see, and then you can, through actually identifying the spectrum, the ionic spectrum, with machine learning, you'll be able to find out the content of the fat, and then you may be able to have this sort of a diagram also. And this is the fatty liver. We'll be able to find out this spectrum, and then we may be able to give a color code in there, and we can give very accurate measurements also. This is an example of machine learning. Machine learning technology, which we can actually measure the fat in the liver, measure the fibrosis in the liver through the machines. It's not the modern medicine capability; it's the machine capability. We are just inculcating that. So with that, I will just go to the management. I will not actually take you much time in the management because I want to have discussions on this. Here I feel there's a lot of scope here for integration, collaboration, because this is an area with the problem of which in fact I have pictured to you. It's a big problem, But right now we don't have much to offer here, other than the lifestyle modification. There's a diet, exercise, and weight loss. We have got a lot of molecules under development, probably about 250 or 260 at various stages of development, But the golden truck, the all effective truck, is yet to come. So here we find that any of the modern medication, in fact, is not above what we achieve through this lifestyle modification of diet, exercise, and weight loss. So that is the current scenario. And here, so that actually opens out quite a lot of possibilities, for integration, collaboration. Diet, well, we need to, I think, identify diet if you advise with poor compliance, for our patients. And then probably I'm aware that, you people, you have got more dietary, manipulations, more acceptable dietary manipulations. So we need to find out and define probably an Indian healthy diet or a South Indian healthy diet or Kerala healthy diet, which you may be able to promote for our patients, which will be more acceptable and which will. So there's efficacy and acceptability. So I think we're looking forward to you for this. They say no alcohol. And then exercise also the same thing, Well, their exercise, it will actually bring down the condition, but there's a poor compliance and acceptance by the patients, But here, well, I know that the yoga as an exercise, yoga is not just an energy spending exercise, because I am also involved in some of the studies of yoga as an exercise for liver condition, fat, and for IBS, So yoga is not just an energy spending exercise, I know. It is, in fact, it triggers, different types of the cytokines. I know we have a evidence there, So the different yogic postures can probably stimulate different areas, producing different cytokines, You need not actually go for molecules, You can just by biological modification, remodeling, you will be able to manipulate through yoga. So I feel that yoga has got tremendous capacity, and this is accepted by the medical world, modern medical world also, and the WHO. So I think we need to have more of your views and probably more of research also, in modern terms. So we need to have a language, for a language for discussion. For dialogue, there should be a language, and then be used to use this particular dialogue through this language, effective language, and identify the areas of interest and probably efficacy in modern medical terms. So I just, if you have the patience, I just run through this slide. This will tell you that, fatty liver disease, first there is actually status of fat accumulation from the free fatty acids or de novo fat synthesis. And then it will be actually going for different metabolic stress through microbiota of the intestine, and there are other environmental factors, genetic and epigenetic factors, and it goes for inflammation. Apoptosis is a sort of, a destruction. And then it undergoes oxidative stress, and finally leading on to inflammation, fibrosis, and cirrhosis and liver cancer. So we identify the various interactive, the molecules and the cytokines, and then we try to identify various molecules, biologicals, to interfere with these situations, And hence we have got here a lot of medicines, molecules developed and put under trial, phase 1, 2, 3, 4, and then so these are the trial molecules available. So I think the Indian research is in fact going on, but we know how it acts and where it acts. So from the animal models, from the biological models, from the molecular models, where there is a PPAR agonist. I'm not going into the details about that. Elafibranor is there, 5-glucosone is there, saroglucosone is there. So a lot of trials are there. So before we put into a trial, we know in the molecular level what it actually is doing. And we have confirmed it at the tissue level and the animal models. And then we put it into the human beings for sort of experiments, for controlled trials. So that is how we develop molecules, And just to give you some idea, and probably viewers will be able to figure out, areas where we will be able to collaborate. So I think I'll stop here and I'll give you this take-home messages that, epidemiology and biostatistics are very important tools to assess the disease burden. So we should know, well, what we are going to deal with, how much resource we are going to invest there in terms of your money or energy, something like that. So I feel that, there you should expand there. It should be in the basic curriculum, you should inculcate, you include the epidemiology also. The modern diagnostic intervention technology, which I have highlighted that, the molecular and bioelectronics domains can be shared with modern medicine, I think you need to share that, probably, well, you will have better understanding of the situation, And artificial intelligence, when you have too much of data, you don't be able to process in your mind or during your discussions when a few people are actually grouped together, There, well, just like this, there should be machine learning. There should be a computer to help you. It's just like, in the space. You land your satellite in the moon or the Saturn, not with your mechanical methods, This is the computer which actually is landing on the surface, So this is this is machine learning. So this artificial intelligence, you have to wide data at the molecular level, This you can't comprehend. You won't be able to find what this is exactly. But the computer will tell you, what this data means. It will process for you. So I think the machine learning is something in a big way is coming to all the research at the molecular level. So the research is most at the molecular level, and actually is governed by the artificial intelligence, And probably your molecules also can be put to, and you will be able to analyze your molecule, definitely, and what it does, and where this is going to act at the subcellular level, what is it doing with this sort of cytokines, etc., etc. You will be able to find out, definitely, It's not very difficult. It's much more easy than you think. So deeper knowledge in the pathogenesis is the key factor for drug designs, which I have shown you. And there's a need to generate clinical evidences to practice evidence-based medicine. So when we talk about evidence, I'm very much impressed when Dr. Gangad told about this evidence-based medicine in Ayurveda, which was there for centuries, together, But I can tell you that, evidence-based medicine, the practice of evidence-based medicine came into the modern medicine only just 4 decades ago. Only just 200 years of history, and this evidence-based medicine came just 4 decades ago. But in 4 decades, we have expanded, or I should use the terminology, we have exploded like anything. So that's the difference, So collaborative research with modern medicine will give Ayurveda an easy access to the all above capabilities. This is what I feel, So we need to have discussions. We need to have dialogue through a common language which we understand each other. And this together we should work for a sort of integrated approach, to provide a holistic approach to the other medical world. So I think I'll stop here and I'll take up questions. So once again, thank you very much for the opportunity granted to me. I'm very much excited to have discussions with the doyens and the pioneers in the field. I'm very much excited. And I feel that the future for integration with all these views and understanding of the pioneers and leaders in Ayurveda is going to be very, very bright. So thanks again for the patience.